A solid body rotates with deceleration about a stationary axis with an angular deceleration beta proportional to under root omega, where omega is the angular velocity. Find the mean angular velocity of the body averaged over the whole time of rotation if at the initial moment of time its angular velocity was equal to omega naught. What we have to calculate? We have to calculate the mean of angular velocity, and the formula for mean of angular velocity, that is to be averaged over the time interval. Time interval, which time interval? Time interval 0 to t means the time interval over which the body will rotate. It has initial angular velocity omega naught, and it is deaccelerating, means finally it will stop. So 0 to t is the time for which the object, this solid body, is rotating. So we have this result 0 to t dt. Now we don't know what is omega, and we need omega in terms of t, means omega as a function of t, and also we don't know what is t, what is the time interval over which the body will rotate. Now what information is given to us? He is saying that this body is deaccelerating, so beta is equal to minus c under root omega. C is the constant, and this minus sign shows that the body is deaccelerating. Now we can write beta as d omega by dt. It is equal to minus c under root omega, or from here we can write omega raised to the power minus 1 by 2 d omega is equal to minus c dt. Now if I integrate this equation on both sides, clear? So I will get omega raised to the power 1 by 2 into 2 is equal to minus ct plus constant of integration. Now what is this constant of integration? Using the initial value situation, taking t is equal to 0, at t is equal to 0 the initial angular speed is omega naught. So from here I can write at t is equal to 0 k comes out to be 2 omega naught raised to the power 1 by 2. Now substituting this value of k here, I will get 2 omega raised to the power 1 by 2 is equal to minus ct plus 2 omega naught raised to the power 1 by 2, or from here I can write omega equal to minus ct by 2 plus under root of omega naught raised to the power 2. So we get this function of omega in terms of t. Clear? Now using this result we can find out this omega, but we have not calculated this t so far, so we can calculate this t by putting omega is equal to 0, because we have to calculate the time for which the body is rotating. So if we put this omega is equal to 0, from here we can calculate that t comes out to be equal to 2 by c under root omega naught. Now using both these values for omega and t, we can evaluate this mean value of angular velocity. So if I put this omega as minus ct by 2 plus under root omega naught whole square, integration is from 0 to t, the value of t is this, we have calculated dt, divided by, from here I can write this omega average is equal to 0 to t c square t square by 4 plus omega naught minus ct under root omega naught dt, divided by clear. And if we further solve it, so we will get c square t cube by 12 plus omega naught t minus ct square by 2 under root omega naught divided by t. Now we can take t common from the numerator, and we can write c square t square by 12 plus omega naught minus ct by 2 under root omega naught, and the limit is from 0 to this value of t, that is 2 by c under root omega naught. So if I substitute the value of this t here, so I will get c square by 12 square of this value, that is 4 by c square omega naught plus omega naught minus c by 2, value of this t is 2 by c, this omega naught and this omega naught will give omega naught. So from here we get minus omega naught, this is plus omega naught, this gets cancelled, c square gets cancelled, 4, this 12 we get 3. So the final answer is omega naught by 3, and this is our result.